Thanks everyone for joining today. Today's Golang in London. Sorry, a few teething technical issues at the start, but it looks like we're there now. So we're joined by James Thimont, as obviously everyone knows today, for a great talk. Just quickly before we get into it, I will be recording this event, so if anyone misses anything, don't worry, it'll be uploaded to LinkedIn, if not this afternoon, tomorrow mornings. So keep an eye out for that. Simply, if anyone's got any questions, if you want to just stick them in the chat function during the talk, we'll have some time at the end to go through them. But yeah, just to leave James going with it. So yeah, as I said, joined by James today, CTO at MachineMax, previously BCG Digital Ventures. I'm sure a lot of people here know a lot about both companies. Talking about building with IoT and generally everything around that. I mean, that's it from my side, really. As I said, I'll be recording it, admitting people from the waiting room. So I'll hand over to James now. Yeah, go ahead.
Thank you, Rory. Hi, everyone. Thank you for listening to me today. I am going to turn my video off just to conserve bandwidth on my side. And Rory, if you could just tell me whether you can see my screen.
Not at the moment.
Okay.
Yep.
Yep, you can see the first slide.
Yeah, all good.
Brilliant. Well, it's been a couple of years since I started at MachineMax, and I've learned a lot about IoT along the way. And I just thought it'd be quite interesting to share some of these insights with you. And something I found really surprising on this journey is that there are not really that many examples of really successful IoT companies. And considering all the recent technical advances, so more energy efficient processors, better batteries, advent of low power networking technologies, etc., I do think it's still a great time to be working with IoT. And hopefully after this talk, you'll be inspired to look into the area a little bit more closely. I will start by talking about MachineMax. And this is not to turn this session into a 30-minute sales pitch at all. It's really just to give you a bit of context. MachineMax spun out of the incubator BCG Digital Ventures. And BCG Digital Ventures is an incubator with a twist. All of the businesses are built in collaboration with a really large company. So you get to combine the startup style execution capabilities and accelerated journey to product market fit from DV with the corporate assets. And it might be capital, it might be brand, it might be customer base. And when you combine these things, you really increase the chances for the success of the new company massively, which is a great thing. As we know, it's a tough world for startups out there. And MachineMax is a JV between Shell and DV. And the goal really was to build a business that would help Shell get a bit closer to its end users and consumers of industrial lubricants. And companies in the mining and construction sector are big customers. So we did a lot of research out there, and these companies are operating fleets of really expensive heavy machinery. And I'm talking about those big yellow machines that you see by the side of a road on a construction site. And they're operating these fleets, but they really have very poor visibility on what the machines are up to. And this translates into poor productivity. A great example of this is idling. And idling is defined as when a machine's engine is running, but it's not actually working. And machines idle about 40% of the time. Now, this is a really big problem for companies, but it's a great opportunity for MachineMax, because even small improvements that we can help companies make using the data have a really big impact. And this impact is in productivity and profits. And we've calculated the opportunity space to be in the tens of billions of dollars across the globe annually. And really the root cause of this problem is that it's very hard to get the right activity data of these machines. And occasionally it might be available, but it tends to be siloed at different parts of the value chain, as you can see here. And a lot of the machines even are just not connected at all, so they don't have any telematics on board. And all this makes it really hard for fleet owners because they don't have a holistic view of their fleet. And you need a holistic view of your fleet if you're going to make decisions and change things on site. So MachineMax solves this in two really neat ways. We've got a very cool device, which is battery powered, so it's really easy to install. You actually just walk up to the side of the machine and it's got some powerful magnets on it and it sticks to the side of the machine. And we sampled the vibrations of the engine using an accelerometer. We can transfer these to the cloud and then apply machine learning on them. And we can infer whether the machine is working, whether the engine's on and it's just running idle, or whether it's off. So we pump all of this data, along with data from third-party GPS trackers and also the onboard telematics systems on the machine themselves, into our platform. And then we provide various analyses and present these to the customers in really simple and intuitive fashion. And this is the really important thing. Don't overload your customers with data. Focus on the actionable insights and present them in a really accessible manner. I'll give you a few more details on the sensor here. I mean, one thing that's really cool is that it's only the size of an iPhone really, and about an inch thick. And yet we still managed to eke out battery life of about 18 months. And I think the design is something which is really cool too. It really seems to be something like you might see in a Batman movie to me. So MachineMax does build some really awesome hardware, but the thing about IoT businesses, they are not hardware businesses. From an engineering point of view, I know that messing about with the devices, Raspberry Pis, Arduinos, etc., getting lights to go on and off, buzzers to go on and off, that's the fun bit, isn't it? But the real value comes from the data. MachineMax's customers are paying for the insights that enable them to improve operations on site. They're definitely not paying for sensors. And if we consider an analogy, say we weren't setting up an IoT business, but say we were setting up an agricultural business. I already know the exciting bit, and I can tell you this as someone who's played a lot of top trumps as a child, is looking at all the different machineries, comparing their specs, selecting the one with the biggest engine, et cetera, looking at the different tractors, combine harvesters. You know, this is the exciting bit, but where does the actual value of the business come from? Well, it's the crops. So you can have the most advanced machinery harvesting capabilities, but if you're bringing the wrong type of crop to market, or even the wrong quality of crop to market, your business is going to fail. And it's really important not to lose sight of this when you're building an IoT business. The value always comes from the data and not from the devices. So what's the data that we need at MachineMax? Well, it's utilization or machine activity data. And so much as your Fitbit or Apple Watch can tell you whether you're moving or whether you're sitting down, we need to know whether the machines are working, whether they're on and running idle, or whether they're off. And as I've said, a lot of the machines are not connected at all. Some of them do have telematics on board, but the thing is they don't capture the useful data. So it's almost like with the crops, you know, not bringing the right crop to market, or perhaps the right quality of crop. Because the onboard telematics systems may report idling, but they actually base it on the engine revs, which means it's really easy to fool. And we see many examples of operators tricking the machine. As an example, what they do quite often in the winter is they may want to sit in the cab and turn the heating on because it's cold. Now that would be classed as idling because the engine's on, but the machine's not doing any work. So what does the operator do? Sits there and occasionally taps the accelerator pedal, which brings the revs above the idling threshold. And so the onboard system thinks that the machine's working when it's actually not. So you may get idling data, but the thing is, it's not really useful idling data. And so then what you typically had to do and what we had to do is you've got to think about a proxy. And we had this great insight that actually looking at the engine's vibrations is a great proxy for what the machine is doing. And if you want to try and capture engine vibrations, it's great to have an accelerometer. So we went and had a look at the various off-the-shelf devices with an accelerometer, but unfortunately none of them really fitted the requirements that we had. We definitely wanted something that was battery powered because simplicity is one of the key tenets of MachineMax. And so it needed to be really easy to install. And so there's no way that we could connect wires to the engine, etc. That would just be too difficult. So it needed to be battery powered. We needed to have decent battery life. And then it also had to operate in quite challenging environments. Consider the middle of the Canadian winter, or it might be under the midday sun in the Middle East. You know, it can't fail under those conditions. So we realized very quickly that there unfortunately wasn't a commodity device that would fit our needs, and we'd have to build some custom hardware. And I'd really say if you get the opportunity to use a commodity device in your IoT setup, go for it. It makes your life considerably easier. We did have to go for custom hardware, which come with a lot of challenges. But the great thing is, if you manage to get custom hardware right, it should be a really big differentiator for your business. And this is because building hardware is hard. First of all, there are loads of constraints. Battery power is a big one. One of the biggest drains on battery with IoT devices is actually transmitting data. And because all the value comes from the data, you know, that's the really important part. And so if you want to conserve on power, you probably want to use some low power networking protocol, which means then you have very low bandwidth. So that reduces the amount of telemetry data that you can transmit, but it also rules out some things such as over-the-air updates, which means that when your device ships and that version of the firmware, it's probably got to last for a year or more without being able to be updated. You also don't really have much capacity on board the device. So we had actually less than 500 kilobytes for the firmware. And I know this is a Go talk, but unfortunately Go would just definitely not fit. For instance, even the Go runtime wouldn't make it into that space. There's a really long release cycle on hardware. I think you'd be lucky to get something to market within 12 months, realistically. You have to think of all the different components that you might need. You have to test that they work together. You have to make sure that the firmware works with all these different components. And then you have to go through various stages of certification, just so that you can actually sell the thing. And it's interesting comparing that release cycle, say if your background is web development, because if you're doing a really good job, your release cycle on the web could even be measured in seconds. And as you do have this really long release cycle, it's really important to keep your options open as long as possible. So maintain optionality, because early on your business is rushing to find product market fit. But on the engineering side, you're really rushing to find product technology fit. Which are the components that you think you need on board? You know, do you need a GPS chip or not? Will you do location tracking? Which is the most appropriate networking protocol? Is it LoRaWAN? Is it narrowband IoT? You're probably not sure up front. So you really want to build a board that accommodates all of these technologies. So then if you do want to change them at some point, you don't have to go through the full release cycle. And even though unit economics are really important for the business as it scales, you definitely do not want to optimize for the unit cost of the device in your first version. I know that everyone has dreams of their first device going out to thousands, tens of thousands, hundreds of thousands of customers, but in reality, what you want to do is incorporate the learnings from those first few months into rapidly building a more appropriate second version and getting that into market. It's also really important to focus your risk taking. So for instance, do you want to use an experimental new networking protocol? Or perhaps you could use something which is tried and tested. Perhaps you could simply use 2G. You know it will work. And when I told people about our device and how it measured vibrations, often people would ask me, oh, have you considered energy harvesting? Perhaps then you could extend battery life way beyond 18 months. And the thing is you want to focus your R&D on something which is firstly experimental and high risk, but it's also not providing that much extra value to your customers. Because the trade-off is, well, perhaps I could introduce a bigger battery. Perhaps I could simply replace the sensors more frequently compared to going with some experimental new technology that's just energy harvesting. Field deployments are also very different. I know that in the developer world, there's a typical phrase, which is, well, it worked on my machine. Well, the IoT equivalent really is, well, it works in the office. And I can tell you that the office is quite different to the field. Many of MachineMax's sites are in really remote areas where perhaps there's not even cellular reception, or they could even be deep underground, operating at a mine which is deep underground in Zambia at the moment. And so then you have to start thinking about things like, well, perhaps I need an offline mode. What happens if the device goes out of network range? I can't afford to lose the data. So perhaps the device needs some kind of buffer. And then the question is, so how does the device know when it should retransmit the data? Perhaps you're using an ACLES protocol such as LoRaWAN, so the device doesn't even get notification that the packets have been received by the server. And one of the really, really important things because of this challenging environment is that reliability is key. And I think you have to have a quite different mentality to developing other applications, because the application, it has to know itself whether it is healthy. In some other environments, and we're talking about app development, say, or perhaps some server-side code, typically it's okay to let something else know whether the application is running correctly. And a person who's using an app and sees that it freezes will kill it and restart it. If the app crashes, the user will restart it. Perhaps if you're running something in Kubernetes, if your server application stops responding, well, the Kubernetes supervisor will know that and can kill it. But the device itself not only has to keep running, it has to know that it's in a healthy state, because the firmware could be running, but if there's some problem with the settings in, say, the cellular or the networking stack, which means it's no longer able to transmit messages, then it's no good having the device actually running because you're not receiving any of the data. So the device itself has to know that it's not in the correct mode and has to have a way to recover itself to get back to a healthy state. And this also leads to monitoring. This is something that you have to really think about, because as customers come to rely on your data to change the way that they work, it's really important that it's not just accurate, but it has to be complete. And so you have to know that all of your devices across your fleet are working correctly. And you also want to be able to determine that the problem is actually a problem with the device and not perhaps just operating conditions. For instance, if you start to see a lot of devices are not transmitting data, well, it could be that in fact machines have moved to a site where they're out of range, or it could be that one of your gateways has gone down. But you really have to know what the problem is. So you have to put a lot of effort into thinking, what are the metrics that I have to be looking for? How do I know that my deployment is healthy? And then you need to think about putting all of your data together so that it can be easily queried by a business analyst. You definitely don't want your developers to be spending time extracting data and querying it and putting it into the correct format. So you definitely want to denormalize the data as much as possible and combine your telemetry data with your customer data with your device data. So it's all in one place, in one data warehouse. And because a lot of the value really comes from data, it's quite likely that you're going to apply some sort of machine learning to it. And machine learning with IoT data, and machine learning doing something in the field, has some really big challenges. I mean, one of the big things is, how do you get training data? So for us, we needed to be able to capture the vibration data and actually map it one-to-one with the states that we'd observed. So an obvious way of doing it would actually be to go out into the field. But the challenging thing is, if the field itself could be hours away from your office, it could be really inaccessible. Or you could perhaps not even be allowed to go to the site. You know, there might be HSE requirements. It might be a sensitive site. You might not even be able to visit. And one thing that we considered doing is attaching cameras to the top of the cabs. So to be able to combine that video and a timestamp with the data from the sensors. And then one thing that we learned quite quickly is that often these embedded devices have onboard clocks, which can exhibit some drift. And so your onboard clock of the device might be 5 minutes out from the actual observation on the video. And so you have to come up with a way to correct that, because obviously you don't have NTP on these kind of devices. Or it could be recorded video, but one of the really useful things is actually being able to hear the engine, and you're on a really noisy site, and that doesn't come across from the video. And validating the model is also something which is really, really challenging. I think for a lot of our cases, it was reasonably clear from the vibrations whether the machine was working or whether it was running idle. And if it's something that humans can see by just looking at the difference, then that's a really big plus, because then you can extend your validation to a kind of mechanical Turk type setup to help you do that. But we were also looking at some quite atypical machines, such as cranes. And then considering the activity of the crane is considerably harder just from the eye. I mean, you really have to be there on site to see what's happening. And even looking at the vibration data, it's the kind of thing that really you need machine learning to extract the useful bits of vibration to determine what a crane is doing compared to a person. So even if you have managed to create this great model, as I say, you have to expect the unexpected. One of our customers came to us and said it was quite surprising, because they didn't actually work in nights, but over a weekend, some of their machines were showing up as running active overnight. And this was something which was really strange to us. And we took a bit of time trying to figure out what the cause was. But we actually went and had a look at some of the weather data. And it turned out that there was really strong winds and heavy rainfall on that site over the weekend. And then our sensors started to pick up the vibration of the rain hitting the device and interpret it as working. And that's the kind of thing which is so hard to envisage and so hard to predict if you're sitting in there in the office as a data scientist. And there's one thing that we would really do is encourage our data scientists to get out to the field and try and see what the operating conditions were like, and incorporate that kind of thinking into their modeling. So it becomes, data science starts becoming quite a lot more practical when you're dealing with IoT than theoretical. And the big thing is, as I say, customers are relying on your insights. So the models really have to be accurate. It's really important that customers keep faith in the data that you're presenting to them. And I'll just give you a quick example here of the kind of custom validation tool that we had to build. And I think you it's quite likely that you'll have to end up building something yourself working with IoT. But this is the combination of the raw vibration data with what the model is predicting. Because for any kind of debugging and troubleshooting, it's really important, if you get any queries, for you to be able to look at the raw data and say, well, I know you think it's surprising that your machine is idling 10 hours a day, but if we look at the data, it's clearly the case. So finally, in summary, IoT is really hard, but the opportunities are really big. And it's partly because of the sectors are so big. For instance, construction is about 5% of GDP in the UK. And often because these kind of industries are really ripe for disruption. And something that I find really exciting is working for a business where you can have a really big impact on a really big industry like this. And so this is really where I want to conclude, but I do know that this was a Go talk, and we do actually use Go extensively at MachineMax. As I said, it's not really that appropriate for an embedded device because of the constraints, but we do deploy certain devices in the field, such as gateways, which are a bit more like Raspberry Pis, and being able to build a single deployable unit as you can with Go is super helpful. And then the rest of our platform is typically built in Go. Certainly we use Python for data processing, machine learning, but there are some great opportunities for Go engineers within MachineMax. And I can say we're also looking for a super Go engineer. So if any of you are interested, please get in touch, or if you know someone who you think might be, please get in touch. But otherwise, I'd love to hear any questions.
Great, thanks, James. Yeah, as you mentioned, any questions, either in the chat or just speak up, whatever's easiest.
Preferably no hard questions from the MachineMax people online.
Hi, can you hear me?
Yep.
Yes.
Just completely out of curiosity, have you tried TinyGo for embedded Go? It's another compiler and runtime combination.
It's the kind of thing that we look at. But again, the thing I said is, you know, where do you want to focus your risk taking? C and C++ have been used in embedded devices for a long, long time, and so they have a really great ecosystem. I think the introduction of Rust to the ecosystem is, you know, a great development. But something like TinyGo, I think even, you know, if it's technically feasible, the question is, do we want to invest our R&D, as I said, into that kind of thing, when we could use something which is perhaps as appropriate, but certainly better supported, such as C and C++. But, you know, honestly, I'm always on the lookout to use Go in as many places as possible.
Diego's asked in the chat, in which type of devices are you embedding Go apart from Raspberry Pi?
Well, actually, so we use LoRaWAN, and the way LoRaWAN works is the devices communicate with a gateway, so much as your phone connects with a router at home. And then the gateway actually has the internet backhaul, and quite a few of the manufacturers actually base their design on the Raspberry Pi. So it's almost like having a Raspberry Pi within the gateway. You know, that's a great candidate, so we can run monitoring and data applications on that.
Anyone else?
What kind of C++ do you use on the embedded devices? What toolchain?
Honestly, I think it's pretty standard. I will definitely defer to our hardware engineers there. Is the honest answer.
I think, just to chime in, I think it doesn't have the STL. It's pretty basic. It's I think it's an STM based board, STM32. So it's quite standard, exception free, no STL kind of C++.
Okay, thanks.
Is that everyone then? Sounds like it. Cool. Well, yeah, thanks. Obviously, very much, James. Really interesting talk. As I mentioned, this has been recorded. I know a few people came in 5 or so minutes late, so don't worry. You'll be able to see the full talk either this afternoon or tomorrow morning. Apart from that, keep an eye out on the group. I'm also growing out the Python in London meetup group, which some people in here may be interested in. A bit of crossover sometimes. I've also got some colleagues. If you check out the Oliver Bernard website on our community page, we've got colleagues in all areas, really doing some talks, all areas of tech, but also stuff like Agile London, which might be of interest more generally. But for this one, keep an eye on the group. And thanks again very much, James. Really great talk today.
Pleasure. Thanks for listening, everyone.
Cheers, guys.
Cheers.
Bye.